Imagine traveling more than 4.5 billion kilometers away from Earth, to a place where the sun is just a pale star in a black ocean. Out here, near Neptune, sunlight is almost 1,000 times weaker than on our planet, and the warmth that sustains life on Earth fades into a deep, endless cold. Yet even in this frozen darkness, a giant world waits, glowing a mysterious blue against the void. This is Neptune, the most distant known major planet of our solar system, often called an ice giant because of the water, methane, and ammonia hidden deep beneath its clouds. It was not discovered by accident through a telescope, but predicted on paper first. In the 19th century, astronomers noticed that Uranus was not moving exactly as Newton's laws predicted. Something massive, unseen, was pulling on it. Using mathematics alone, scientists like Urbain Le Verrier calculated where this hidden planet should be. When telescopes were finally pointed to that position in the sky, in 1846, there it was, a faint blue disk, a planet found by equations before the human eye ever saw it. Since that discovery, Neptune has barely moved. It takes about 165 Earth years to complete just one orbit around the Sun, which means Neptune has only finished a single year since we first observed it in the 19th century. Imagine a world drifting so slowly through space that no human being has lived long enough to see it go once around its star. It moves in near silence, tracing a cold, distant path at the edge of our planetary system. From far away, Neptune looks peaceful. Smooth blue hues, soft bands of clouds, a serene marble hanging in the dark. But this calm appearance is deceptive. Neptune is a world of extreme physics, a natural laboratory of atmospheric chaos. Its atmosphere is made mainly of hydrogen and helium, with a small amount of methane that absorbs red light and gives the planet its deep blue color. Beneath that beautiful shade, however, lies one of the wildest weather systems in the solar system. Neptune holds the record for the fastest winds ever measured on any planet. Spacecraft and telescopes have detected winds that can reach around 2,000 kilometers per hour, faster than the speed of sound in air. These are not gentle breezes. They are hypersonic jets of gas circling a world where temperatures in the upper atmosphere can drop to around minus 220 degrees Celsius. If a human could stand there, which is impossible, the force of these winds would tear matter apart long before any sound could be heard. The question is, how can a planet so far from the sun have such violent energy? The answer points inward. Neptune receives very little solar energy, but it radiates significantly more heat than it gets from the sun, suggesting a powerful internal heat source. Deep inside, under enormous pressures, the materials that we call ices, water, ammonia, and methane, are compressed into hot, dense forms. The planet's interior likely contains a superheated mantle of these substances, possibly with exotic states like superionic water, where molecules behave in strange ways under pressure. This inner heat rises through the atmosphere, driving storms and winds that make Neptune's weather so extreme. In 1989, NASA's Voyager 2 spacecraft became the first, and so far only, probe to visit Neptune up close. As it flew past, it saw a gigantic storm system in the southern hemisphere, a dark, oval-shaped vortex almost the size of Earth, known as the Great Dark Spot. It was like an enormous hurricane in a hydrogen sky, bordered by bright methane clouds racing around it. This storm showed that even at the edge of the solar system, planetary atmospheres can be incredibly dynamic. But the story did not end there. When the Hubble Space Telescope observed Neptune years later, the original Great Dark Spot had vanished, as if wiped away. Then, new dark storms appeared in other regions of the planet. Unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune storms seem to form, drift, and then disappear, as if the planet is constantly breathing in and out chaotic weather patterns. These short-lived tempests challenge our understanding of how storms evolve in such cold, fast-moving atmospheres. If we could dive beneath Neptune's cloud tops, the environment would become even more extreme. Pressure would skyrocket, temperatures would rise, and simple molecules would be forced into unfamiliar forms. Experiments and computer models suggest that deep within the mantles of ice giants like Neptune, carbon atoms may be squeezed so tightly that they form solid diamond structures. Under such conditions, it is possible that diamond hail or rain could fall through layers of hot, dense fluid. Imagine a hidden ocean of high-pressure water and other compounds, heated to thousands of degrees, with diamond fragments slowly sinking through it like glowing stones in a dark electric sea. Deeper still, the temperatures may reach thousands of degrees Celsius, hotter than many places on the surface of the sun, even though the outer atmosphere remains bitterly cold. This contrast, frozen clouds above, blazing interior below, makes Neptune a planet of contradictions. It is both an ice world and a furnace, a place where common materials like water and carbon behave in alien ways. Neptune's strangeness does not stop at its atmosphere and interior. Its magnetic field is another mystery. Unlike Earth, where the magnetic field is roughly aligned with the planet's rotation and centered near the core, Neptune's magnetic field is tilted by more than 45 degrees and shifted far from the planet's center. This creates an uneven, twisted magnetosphere that interacts with the solar wind in complex and changing patterns. The result is a magnetic environment that challenges our models of how planetary magnetic fields are generated in such interior conditions. Orbiting this strange planet is Triton, Neptune's largest moon, and one of the most fascinating objects in the solar system. Triton likely did not form around Neptune at all. Instead, scientists think it is a captured object from the Kuiper Belt, a distant region of icy bodies beyond Neptune's orbit. Once an independent world drifting through the outer solar system, Triton was caught by Neptune's gravity and forced into a retrograde orbit. It circles Neptune in the opposite direction of the planet's rotation. Voyager 2 revealed Triton as a frozen but active world. Its surface is made of nitrogen and water ice, with regions that appear geologically young. Even more surprising, Voyager saw evidence of cryovolcanism, geysers or plumes of nitrogen gas erupting from the surface, driven by subtle heating beneath the ice. Surface temperatures are among the coldest recorded in the solar system, close to just a few tens of degrees above absolute zero, yet the moon is not completely dead. Inside, tidal forces and possible radioactive heating might be keeping some layers active, and some studies suggest Triton could even hide a subsurface ocean. But Triton's orbit carries a dramatic future. Because it moves opposite to Neptune's rotation and slowly spirals inward, it is on a long-term path toward destruction. In the distant future, gravitational forces will likely tear Triton apart as it crosses a critical distance called the Roche limit. When that happens, its fragments could spread out to form a new, massive ring system around Neptune, turning the ice giant into a world crowned with the remains of a shattered moon. Beyond Neptune's orbit, the sun's gravitational grip weakens, and the solar system begins to merge with the vast interstellar space between the stars. In that sense, Neptune is like a final gatekeeper, the last major planet before the long journey toward the Oort cloud and the true emptiness beyond. It stands as a reminder that our home system is larger, darker, and more complex than the inner worlds alone suggest. Neptune shows us that the universe is not designed for our comfort. It is a place of extreme cold, invisible forces, roaring winds, and crushing pressures. And yet, it is also a place of beauty. Blue clouds lit by a distant sun, rings made of dust and ice, and moons with active, icy geology. By studying Neptune, space agencies today are not only learning about one distant planet, they are also unlocking the secrets of countless similar ice giants that we now discover around other stars. Future missions proposed by agencies like NASA and ESA aim to return to Neptune and Triton with orbiters and landers to map their surfaces, measure their magnetic fields, probe their interiors, and maybe even confirm whether diamond rain and hidden oceans truly exist there. Each new mission would turn this distant blue point of light into a detailed living world in our understanding. If you want to keep traveling to places like this, to the edge of our solar system and beyond, and explore more incredible stories about planets, stars, and galaxies, make sure to subscribe and join us for the next journey through the cosmos.